Section 6.2 is on normal curve application problems. These problems are very similar to the problems that we had in the last section, except these problems are not about standard normal curves. They're about normal curves with different means and different standard deviations. At the end of the day, all of the problems are going to boil down to being ones exactly like these that we saw in the last video. There's just a few extra steps that we have to take to get there. We'll start this by looking at one example, and then we'll go through a few more examples so you have a better idea of what to expect. So let's say that we have scores on some type of exam have an approximately normal distribution with a mean of 67.5 and a standard deviation of 4.5. We're being asked to find the percent of scores between 63 and 76.5. The fact that they told us these exam grades were approximately normally distributed or had an approximate normal distribution tells us that we can solve this using normal curve tables or using the calculator. First, we'll go through how we would do this without the calculator. This is not a standard normal curve problem because our mean is not 0 and our standard deviation is not 1, but we can still use some facts that we know about normal distributions to give us an idea of what direction we should head in. First, we'll try and draw what's going on here. Now, we know that the mean goes in the middle. So even though our mean isn't 0, we know that it's directly in the middle of this curve. So that's where 67.5 is going to go. And we know 63 is below the mean, so that'll be somewhere here. 76.5 somewhere above the mean, that'll be somewhere there. So we know that we're going to be looking for a piece of area like this that's touching the mean, something similar to, one of these. Now let's try and get a better idea of where we're going to place 63 and where we're going to place 76.5. If you remember from earlier, before, the plague shut down school and everything else, we had talked about z-scores, where if we wanted to get a z-score, we would take the data point we were concerned about, subtract the mean, divide by the standard deviation, and then this is going to give us a number that we can work with along the standard normal curve. Another way we could get these z-scores is by drawing out a number line, which is what we can do here. If we take 67.5 and add on 4.5 to it, we're going to end up with 72. Then we can add on the standard deviation again, and we end up with 76.5. And then we can do it again, and we end up with 81. We can also do this in the other direction, where we end up subtracting the standard deviation. And now if we take a look at this again, it turns out that the two numbers in here actually do show up as values over here. We had 63 over here, which is a number they had asked us about, and then 76.5 was another number they asked us about. So this is convenient because we can see what area we're being expected to, find the percentage of. And it's this piece of area right here. This doesn't help us with using the tables because we don't know what numbers we're going to look up for these. But if we were to convert all of these from the values that we have here to z-scores, we would be able to do that. 67.5, because it's the mean, is going to end up being 0. 72 is going to end up being 1. 76.5 ends up being 2. And 63 is going to end up being -1. So this problem, we also could have converted these using this formula over here, but if you've written them out like a number line, you can see what they are easily. So anyway, this problem is now essentially turned into this problem, where they want us to find the percentage of area between -1 and +2 under the standard normal curve. And this is something that we can easily do with our tables. So if we pull our table out, we can see the area between 0 and 1 is 0.3413. And then we can add that to the area between 0 and 2, which is right here, 0.4772. And those together give us 0.8185, or 81.85%. We could also have chosen to do this problem on the calculator instead of using the normal curve table. we know our mean, we know our standard deviation, and we have these two values. So the technique that we would use to find this on the calculator is the same as what we did before. The only difference here is with our lower limit and our upper limit, we're just going to take whatever the problem gives us. We know our lower limit in this case is 63. Our upper limit is going to be 76.5. The mean was given to us in the problem as 67.5, and the standard deviation was given to us as 4.5. So these are the values we're going to put in the calculator. So what you would put in your calculator directly is this: normal CDF, 63, 76.5, 67.5, 4.5. Then we would hit enter, and we end up getting 0.81859, which rounds to 0.8186, which will give us 81.86%. These aren't exactly the same, but they're close enough. Now we'll go over some steps for how you can solve these problems in general. So to solve these without a calculator, if you are using a calculator, again, it's pretty much the same concept as last time. The only difference is you're going to be making sure that you put in whatever mean and whatever standard deviation the problem gives you, and you're going to leave your values as the problem gives them to you, unless you need to approximate infinity, which you would do with a bunch of positive or a bunch of negative nines, depending on the direction it's going in. If you are using the tables, the first things that you would need to do is identify your mean and standard deviation and any other important values that you need to work with. In the case of this problem, well, we can see our mean is over here, our standard deviation is over here, and then these are our two important values, 63 and 76.5. Then what you would do is you would calculate the necessary z-scores. In this case, the z-scores that we needed to find were for 63 and for 76.5. So they're always going to be the other numbers given to you in the problem that are not the mean and standard deviation. We'd calculate those z-scores. Then what we would do is draw a normal curve. We'd mark down where the mean is in the middle, whatever the necessary z-scores were, and shade the area we're being asked to find. So this is what we did over here. We can change 63, 76.5 into z-scores. We would mark them down as -1 and +2 over here, and then shade the area we want to find. Once we have this picture, we can now figure out how to use the normal table in order to solve this problem. If we see that it looks like this, we know, okay, well, we have to look up this piece of area, and add the two of them together. Okay, and that's our fourth step. Once you have your picture, you can figure out how to use the normal table. Now we'll take a look at another example. Let's say the number of hours quarantined people have spent playing Animal Crossing has an approximately normal distribution with a mean of 150 hours, which would be hours, and a standard deviation of 7 hours. Now first they're asking us to find the percent of people that have played more than 160 hours. So let's say that we're doing this without using the calculator. What we want to do, even if you are using the calculator, I still recommend drawing a picture of what's going on so you know what your upper and lower limits are. You should always draw a picture of the normal curve involved. First, we want to identify our mean and standard deviation. Those are given to us in the problem. And now we want to find the z-scores that are important. So 160, this is the important number here that they're asking us to work with. If we change this into a z-score, z is going to be equal to 160 minus 150, our mean, divided by our standard deviation of 7. And this works out to be 1.4285. Now, if we're using the tables, it's important to note that we can only go to places after the decimal. So we can't look up 1.4285. We can look up 1.42 or 1.43. So we are going to have to round this to 2 decimal places. So this is the z-score we'll be dealing with. Okay, so we'll draw a picture of this. We also could have started out like this, mark our mean. Our original mean was 150. We know 160 is higher than that. We can place that here. This is going to end up being 0 because it's the mean, and then we saw in our conversion over here, this is going to become, in a z-score, 1.43. and we're looking for the amount of people that have played more than that many hours, so we're shading in this direction. Now that we have this picture, we know how to solve this type of problem using the tables. We would look up the area between 0 and 1.43 and then subtract that from 0.5 because this whole half of the curve is 0.5. So we're going to go to our table. We look up 1.43. So what's this? That's 0.4236. And we subtract, we end up getting 0.0764. Oh, but wait, they asked us for a percentage, so we would have to change this to 7.64%. Okay, that's our actual answer, because they did ask us for a percent. Now let's say we wanted to solve this on the calculator. We could do that, and it's a little bit less work, but we still need to pay attention. You would still need to see this picture just so that we know, okay, well here we're veering off towards positive infinity, so we're going to have to approximate this with a bunch of 9s. We'd go to the normal CDF via the directions in the last video. Our lower limit in this case is 160. Our upper limit is positive infinity, and we're going to throw in a lot of 9s. Then our mean was 150. Our standard deviation was 7. We hit enter, and we end up getting 0.07656. Which is going to round to 0.0766 or 7.66%. Now these two aren't exactly the same, but again, they're very close. So let's say next exam, you get a question like this. As long as you show all of your work, whether you're using the calculator or you're using the tables, you draw the picture, you write down what numbers you're working with, you'll still get full credit whether you end up with 7.64% or 7.66%. Now we'll look at another question. Find the percent of people that have played between 130 and 145 hours. So let's start by drawing a picture. Our mean is 150, so that goes right in the middle. The z-score for that would be 0. And then the two values that they expect us to care about are 130 and 145. Now these are both lower than our mean of 150. So they're both going to go to the left of 150. Now when we find z-scores for this, we expect the z-scores to come out to be negative because they're to the left of the mean. So if you're doing your z-score conversions, you end up with positive numbers, and you look back at this picture, that should tell you that you're going to be making a mistake because any values below the mean should end up with negative z-scores. So we'll do our conversions now. All right, so our first z, 130 minus 150 over 7. That's going to give us negative 2.86 once we round everything off. And then the other one is going to give us, we have 145 minus 150 over 7. That gives us negative 0.71 once we round to 2 decimal places. So we go back here. This becomes negative 2.86, and this becomes negative 0.71. So based on what we did before, when this was just the standard normal curve, we know how to solve this problem. We would look up the area between 0 and negative 2.86, which is the same as the area between 0 and positive 2.86, and then subtract the area between 0 and 0.71. So the area between 0 and 2.86, go here, 2.8, and then we want to go over 0, 1, 2, 3, 4, 5, 6, 0.4979. And then we want to subtract the area between 0 and 0.71. So we go to here, 0.7 over here, and then we want to go over to 0.01, so 0.2611. Subtract, and we get to 0.2368, which gives us 23.68%. If we were to do this on the calculator, similar to what we had last time, except we can clearly see what our upper and lower limits are. We can clearly see our lower limit's 130, and that our upper limit is 145. So on the calculator, we would do normal CDF. Our lower is 130, our upper is 145, our mean was 150, standard deviation was 7. We hit enter, we get 0.2354 if we round to 4 places, which gives us 23.54%. They're not that close. Well, I mean, they're still relatively close. Whichever technique you use is okay as long as you show all of your work. They're still close enough for us. It's not like we're, launching rockets into space and being one, decimal point off is going to send the thing, in the wrong direction and kill everybody. So our purposes, it's okay. So let's look at part C. So now we're being told 10,000 people are playing this game, and we want to figure out approximately how many of them have played for more than 140 hours. So we'll ignore the part about 10,000 people right now and figuring out an exact amount instead of a percentage like we've been before for now. And the first thing that we will do is just treat this like another type of problem and try to figure out the amount of area that's going to be represented as people playing for more than 140 hours. So we'll draw a picture here. Mean was 150. More than 140 hours, 140 is less than the mean, so it's going to go to the left. And then they're asking us to find something like this. Okay, so we know if we're using the tables, we're going to end up in a situation where the z-score is going to end up being negative, and we're going to have to add this stuff here. Okay, so now we'll change 140 to a z-score. So it's going to be 140 minus the mean divided by the standard deviation. This gives us negative 1.43 if we round off to 2 decimal places. So this is negative 1.43, and this is the same as 0. If we look up the area between 0 and 1.43, 1.40, 1.41, 1.42, 1.43 is 0.4236. And then we know this piece of area is 0.5. That gives us 0.9236. But they didn't ask us for a percentage. They asked us about how many people have played for more than 140 hours if there were 10,000 people playing. So what we now have to do here is take, 10,000 people times 0.9236, and that's going to give us 9,236 people. Depending on these problems, sometimes you may need to round. If this came out to something like 9236.5 or something people, you would have to either round up or down because you can't have fractional amounts of people. And now we'll look at how we would solve this on the calculator, which would be, same techniques as before, except here we need to note, we're going off towards positive infinity, so we'd represent this with a bunch of positive 9s. So we have here normal CDF. Our lower in this case is 140. Our upper is going to be a bunch of 9s to represent positive infinity. Our mean is 150. Standard deviation is 7. We hit enter and we end up getting 0.9234, which is still, when we round, which is still pretty close to what we ended up getting before. Then we would multiply this by 10,000 people. And we end up with 9,234 people. And both of these are okay. You can use whichever technique you prefer. Now I'm going to leave this problem up here for a while. What I would recommend doing is pausing the video here, trying to go through this problem on your own, and then I'll walk you through the solution. So here we're told in a college the heights of all male students have an approximate normal distribution with mean 178 centimeters and standard deviation 6 centimeters. Suppose there are 4,500 male students at the college. First, they're asking us to find the percent of heights between 172 and 190. Then they want us to find the percent of heights between 160 and 166 centimeters. Then they're getting a little bit different. C, they ask us if Tom is 184 centimeters tall, about how many students are taller than him. D, if Jim is 196 centimeters tall, about how many students are taller than him. So take a couple minutes to try and solve these on your own. They're similar to the ones we did before, and then I'll walk you through the solution afterwards. All right, so let's get to the solution now. The important information that they gave us here for taking the first steps to solving these problems is the mean being 178 centimeters is important, and the standard deviation being 6 centimeters is important. The fact that there are 4,500 male students, we don't need that for parts A and B. We're going to be using that for parts C and D. For part A, all we need is the mean standard deviation and then the numbers that they give us in part A. So for part A, they're asking us to find the percent of heights between 172 and 190 centimeters. We'll draw a picture of what's going on here. Our mean was 178, so that goes in the middle. Now we want to find the percent of heights between 172 and 190. So 172 falls below the mean, 190 falls above the mean. So we know that we're going to be looking for a piece of area like this. But now in order to use the tables, we have to convert 172 and 190 to z-scores. And this gives us a -1. And then if we convert 190 to a z-score, we get +2. So this is essentially -1, and that is +2, and our mean is 0. So we can look up the area between 0 and 1 and add it to the area between 0 and 2. We get our table out. The area between 0 and 1 is 0.3413. The area between 0 and 2 is 0.4772. Then we add them together and we get 0.8185. Or 81.85%. If we were to do this on the calculator, what we would put in, normal CDF, our lower is 172, our upper is 190, our mean is 178, and our standard deviation is 6. That gives us 0.81859, which rounds to 0.8186. or 81.86%, which is close enough. Now we'll move on to part B of this problem, which is find the percent of heights between 160 and 166. First, we'll draw a picture. Okay, so our mean was 178. They want us to find this percent of heights between 160 and 166. Those are both values that are below the mean. So we're looking for a chunk of area like this. Now what we need to do is convert the two of these to z-scores, then use the tables the way we know how to use the tables to solve for this piece of area. So we convert 160 to a z-score and we end up getting -3. We convert 166 to a z-score and we end up getting -2. Now the way that we know how to use the tables to solve this, look up the area between 0 and 3, and then subtract the area between 0 and 2. The area between 0 and 3, back to our tables, right here, 0.4987, minus the area between 0 and 2, 0.4772. This gives us 0.0215, or 2.15%. If we were to do this on the calculator, this one's easier because we can see what our upper and lower limits are. We don't need to approximate for infinity anywhere. We go to normal CDF, put in 160, 166, mean 178, standard deviation 6, hit enter, and we end up getting 0.0214, which is pretty close to what we had before, or 2.14%. Now let's move on to part C. So part C and D are different, and part C and D, we're going to need to use the information that there are 4,500 male students. So C is saying if Tom is 184 centimeters tall, about how many students are taller than him? So we'll start this off by trying to figure out what percentage of students are taller than him, and then we'll try to figure out an approximate amount given that there's 4,500 male students at the school. So we know that our mean is 178. We know that Tom is 184 centimeters tall, and we want to know how many are taller than him. So that would be represented with this piece of area over here. So we're looking for a chunk of area like this now. So if we're doing this problem with the tables, we have to convert this to a z-score and then look it up. So we convert 184 to a z-score, and we end up getting 1. So this becomes 1. Now we just need to look up the area between 0 and 1 on our table and subtract it from 0.5. Area between 0 and 1 is 0.3413. We subtract that from 0.5. We are left with the amount of area in here, which ends up being 0.1587. So if they just asked us to find a percent, we'd need to turn that to a percent and stop. But they had asked us how many students are taller than him. So we're going to multiply this by the number of students. So there's 4,500 male students. We multiply that by 0.1587, and we end up getting 714.15. Now you can't have 0.15 of a student. So if you want to say this is going to count and we have 715, that's okay. If you want to decide to round down and say there's 714, that's also okay. But whenever we're talking about people or actual units of things that you can't cut up, you can't say like, what's this 0.15, somebody's arm or something? You can't do that. We could say, about 714 students. If you also said 715, I wouldn't take off points for that as long as you're rounding, either up or down to a whole number. If we wanted to solve this on the calculator, we need to, again, take note, this is going off towards positive infinity. We're going to need to approximate this with a bunch of 9s. So we have here normal CDF. Our lower is 184. Our upper is infinity, bunch of 9s. Our mean is 178. Our standard deviation is 6. We hit enter. We end up with 0.1586. Similar to what we had before, we multiply this by the number of students, and we end up getting 713.9. Now, this is going to round to 714 if we round up. So again, we could say about 714 students. Now we'll take a look at the last part of this problem, part D. So here we're being told if Jim is 196 centimeters tall, about how many students are shorter than him. So we can start this out by drawing a picture for this situation. Our mean was 178, that goes in the middle. 196 is above that. And we're looking for the amount shorter than him, so that's going to be the amount to the left over here. So we have this type of area we want to find. We're using the tables. We need to convert 196 to z-score, and then we're going to use that number. So this ends up becoming 3 when we convert to a z-score. And now we can find this piece of area on the table. We go down to 3. We get 0.4987. We know this piece is 0.5, so we just have to add them together. And we get 0.9987. But they asked us for a specific number of students, so now we have to multiply this by the number of male students in the school. So 4,500 times 0.9987 is going to give us 4494.15, which if we, you can choose to round this however you want, but I would say it's about 4,494 students. Now, if we were to do this on the calculator, again, similar thing, except we need to note here we're going off towards negative infinity, and we have to approximate our lower limit with a bunch of 9s, probably more 9s than that. We go to normal CDF. Our lower limit is a bunch of negative 9s to approximate negative infinity. Our upper limit is 196, mean is 178, standard deviation is 6. Hit enter, and we end up getting 0.9986, very close to what we had gotten over here from the table. Then we multiply this number by the number of students, and we end up getting 4493.92. And this will round up to 4,494, which is the same type of thing, which is the same solution that we had gotten last time.